Hello everyone, hope everybody's doing well, hope you're all healthy. It was brought to my attention that I made a mistake a little bit earlier on in the unit. If you just want to scroll back to synthetic division, when I was erasing, a number disappeared. Yeah, here it is. So if you look, 7 plus 10, this was supposed to be 17, and it was originally. And then 2 times 17 should have been 34, giving you a total of 30 here. Okay, and so then the remainder would have been 30 instead, and this would have been 17. Okay, so if you can just make those changes to your notes, I apologize for that. We can begin today's lesson. So yesterday, or whenever you looked at the last lesson, we began looking at polynomial functions and what they look like. And today we're going to get into actually graphing them. Okay, there's a couple of information we should look at first. There's a crazy formula here. This, you don't need to know this. This basically just says a polynomial can have any degree. Like here it says x to the n. We could start with x to the 7. We could start with x to the 73. It doesn't matter. If we did, we would have descending powers here all the way to a constant. This would be our constant. Okay, we can have any power. And whatever the highest power is, that's the degree of the function. So when we say x cubed, we say it's a cubic function if that's the highest power. All right, x to the 4 would be a quartic function, etc. Okay, a couple of quick characteristics of these. So back in grade 10, you did a linear function. If you remember, it was y equals mx plus b. All right, if m, the lead coefficient, was positive, you had a graph that rose to the right like that. If the lead coefficient was negative, then the graph would have fallen to the right. Okay? Quartic, you did that in grade 11. And so here we had this function. We also had it in vertex form, but basically the key is this time you have an x squared. If the a value, the value in front of the lead coefficient, was positive, you had a parabola opening up. If the lead coefficient was negative, you had a parabola opening down. No surprises there. Okay, what we want to quickly review is what happens to these higher powers. If we have some sort of a cubic function here, now there could be x squared and x, etc., but if the lead coefficient of x cubed is positive, if it's positive, you're going to get a graph that rises to the right like this. If that lead coefficient is negative, you're going to get a graph that'll fall. Okay, and this trend continues. Okay, what do you think is going to happen with a quartic? Again, a quartic is one that's going to have a power of 4 with some variation of powers after that. If the coefficient in front of the x to the 4 is positive, then you're going to have the arrows facing up. If it would be negative, down. And you can see this is a little different than the parabola. There's going to be an extra wave as opposed to just a single curve like on a parabola. Okay, quintic. Same idea. If you have x to the 5th and we have a coefficient in front, if it's positive, it's going to end up here with some sort of a wave in here. Doesn't always have to be 3 bumps. It could be 4. Okay, and here you're going to have the graph ending down and something going on in between here. Okay, so that's your introduction. We kind of need to know that. We call that end behavior, this idea of what's happening if the lead coefficient is positive or negative. End behavior referring to what's going on with when the graphs go to positive infinity and negative infinity. You should always keep that in mind when you're graphing. What is the end behavior? Okay, I've got it summarized here. If the lead coefficient is positive, all right, then we have, this is for odd degree functions, by the way, odd degree being x, x cubed, x to the 5th, etc. Then you're going to have this kind of thing with, depending on how many waves in between. If the lead coefficient is negative, then the graph's going to have this kind of behavior. The end behavior will be like that. Okay, and if it's an even degree polynomial and the lead coefficient is positive, then you're going to have the two end behaviors like this, and if you have a lead coefficient that's negative, the end behaviors will be down here. Okay? If you guys have free time, why don't you go look up math dances. I think there's one that tells you how to dance according to these polynomials, depending on what the end behavior of the graphs are. All right, next, the x-intercepts. This is what we started the unit off with. You need to be able to factor so you can find the x-intercepts. Just like you needed the x-intercepts in the parabola, we're going to need it in all these polynomials. Okay, so this is kind of what we spent the beginning of the unit working on. Important for us to remember how to do that. Okay? Okay, let's get started on a polynomial. So this one is already factored for you. You have the 4 factors here, which gives me my x-intercepts. If we make this equal to 0, right? If we make that equal to 0, then I can give you the x-intercepts are 1, 2, -3, and -1. So I could plot those on a graph. Let's put -3, -1, 1, and 2. And so you're saying, okay, well, we've got the x-intercepts. Can I figure out anything else? Well, here's where we're going to learn this idea of what a sign diagram is. All right, now if you think about a polynomial function, what kind of polynomial is this? Well, I see 4x's. If I multiplied that together, this is a quartic function. Okay, so I know that it has end behavior, either both going up or both going down. Looking at the coefficient, the lead coefficient, it's positive, so I can make the prediction that it's going to end up like this. The question is, what's happening in here? Is it going below? Is it touching the x-intercepts, or are they crossing? That's what I have to figure out here. Okay, so what I do is I make a sign diagram, placing the same x-intercepts on it. And what I want to do is figure out, is the graph positive in each of these intervals, or is it negative? I can already see in my graph that it's positive after 2 and before -3. What I want to know is what's going on in between here. So I pick a test point. Let's pick -2. If I take -2 and place it in for each of these x's, what do I get? And I don't need to know the value. Okay, something you need to understand when you do these graphs, you don't need to know how high each bump is going. You know, we just need to know, is it positive or negative? So when I test a -2 in here, I'm going to get -2 take away 1, that will be negative. If I put a -2 here, that will be -2 take away take away 2, that's also negative. Put a negative here, -2 plus 3, that's positive, and -2 plus 1, that's negative. If I multiply these together, I end up with negative. So I know the graph here is negative. Okay? Let's test the next interval. If I want to test here, I'm going to test the value of 0. Placing it into each of these factors, I'm going to get negative, negative, positive, positive. This, if I multiply that all together, is positive. So the interval here is positive. Okay? And you can see they're alternating, positive, negative, positive, negative, positive. That's usually the case. We'll talk about the exception later. Okay, let's go into the last interval here. What's between 1 and 2? A little bit harder. Let's test 1.5 or 1.5. Okay, again, putting them into each of those brackets. I'll kind of emphasize it here. There's 4 brackets. If I put 1.5 into the first one, 1.5 minus 1, that will be a positive value. If I put 1.5 into the next bracket, 1.5 minus 2, that's going to be a negative value. 1.5 plus 3, that will be positive. And 1.5 plus 1, that will be positive. Multiplying this, you end up negative. And so based on that, I can see that at -3, the graph is going to go from positive to negative. At -1, okay, -1 is right here, I can see the graph is going from negative to positive, so it's going to be crossing like that. At 1, it's going from positive to negative, and at 2, it's going from negative to positive. So knowing that, I can now draw a graph with nice smooth lines. So it's going to look something like this. Okay? Again, it doesn't matter if you would draw that line steeper like this. That would be okay. There's no right or wrong there. The only thing that I think is missing is we should have a y-intercept here. How do you get the y-intercept? Well, you're going to find what is the function at x equals 0. So 0 plus 3, 0 plus 1. So if I multiply this, I get -1 times -2 times 3 times 1, which is 6. So this value is 6. All right, there is our first polynomial function graphed. Okay, now you notice there are a few more steps that we should make sure we follow. We did this one, the y-intercept. Okay, the point where the graph changes from increasing to decreasing is called a maximum point. Okay, and then we also have the minimum point. I'm telling you guys, we don't need to know how high those are. We don't need to be too specific. If you really wanted to know kind of an idea of how high they should be, you could do a quick table of values and you could pick a couple of points here for x and find out what the y value is, just so you would know, but you don't have to do that. Okay, point E, a polynomial of degree n can have at most n x-intercepts. We talked about that. If it has degree 4, it could have 4 x-intercepts. Okay, and at most, so if it was degree 4, 4 minus 1, would there be 3 local min or max points? Okay, here it mentions a little bit about table of values. I don't think you're going to need that very often. This is sort of an emergency measure. If you don't know what the graph looks like and you're a little bit confused, then use a table of values to sketch the graph. Sometimes that's just helpful to give us some points just to kind of help us finish off a graph. Okay, the graph should be smooth and continuous, no sharp corners. Remember with parabola, I said no V's, it should always be U's. Okay. All right, so let's graph this one. Okay, first of all, let's take a quick examination. Highest degree is 3. This is a cubic function. Lead coefficient is positive, so this graph should end up like this. Okay, so we know that already. That should play into it when we graph. Okay, before we can do anything, we need to factor this. So let's factor. And we might as well talk about the x-intercepts when we're factoring, because that's really why we are factoring. So let's make it equal to 0. And you should be able to see there's a common factor of x. And then, hey, this is kind of nice. I don't have to do any synthetic division, no long division. I can just factor like this. So I'm going to have plus 3 minus 2. So what are my x-intercepts? 0, 2, and -3. Let's put those on the graph. -3, 0, and 2. Okay, I can find the y-intercept really quickly because I can see that it's already right here at 0. So I'm done that. Let's now look at a sign diagram. Okay, now I already mentioned to you that it's going to end off positive here and begin negative here. I can take a guess that this is going to alternate. because you don't know why they alternate yet, you might want to do a check. So if you test a point here, let's check -1. If I place that into my factored version right here, I would get negative, negative, positive. So you can see the graph is positive here. Okay, and it's going to be negative there. So that should give me enough to graph from negative to positive. Oops, missed it totally. From negative to positive, back down to negative, back up to positive. All right, there's your graph. Okay, again, if you don't like that curve, if your curve when you draw it looks more like this, and maybe it's more shallow here, that's also okay. So if you like that one better, no problem. Okay, if it's bothering you and you wanted to know what is this point, we don't know if it's symmetrical, so we don't know if it's if it's peaking more over here. But if you wanted to find another point, you could say, well, when x is 1, what is y? Because I just want to know. Okay, that's something you can do if you're graphing. All right, and we'll go to this one. This one I'm going to stop and I'll begin a new video because we have to factor this, so it's going to take a little while. So I'll stop this video here, and then I'll do this one on the next video, and that's where the homework will be as well. Okay?